Perfect. Okay. Well, we are going over a chapter 7 practice test. So hopefully you've had enough time to work through as much as you can on your own. You've been able to figure out most of the problems, but we're just going to double check our work so that we can make sure we have all the right answers for studying for our test tomorrow. So let's look at this chapter 7 practice test. Right off the bat, numbers 1 and 2, we're looking at finding the mean, median, and mode of the data set. So this is from our 7.1 notes. It'd be really nice to have those handy. It tells us again how to find mean, median, and mode. So the mean is just the average of all these numbers, meaning I just need to add them all up and then divide by the number of data points there are. So in this case, the mean, I added this up ahead of time. I got 45, and then there are 10 numbers there. So I divide that by 10. So my mean is 4.5. Perfect. The median is probably the most work for solving. For the median, we have to find, remember, median means middle. So I had to line all these numbers up from smallest to greatest. So I have 2 1s. I have a 3, I have a 4, and then there are 3 5s, 5, 5, 5, a 6, a 7, and an 8. And I got all of them there. And then we're looking for the number in the middle. So you can do this a couple different ways. One thing you can do is say that there are 10 numbers. So I'm going to look at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the middle is right in between those. In between 5 and 5 is just 5. So the median here is 5. Or if you'd rather, you could start like crossing them out left, right, until you got to the middle. But the median is 5. And then the mode is just the number that appears the most. And in this case, it is 5. Remember, it is possible to have no mode, so just be careful there. So we got our mean was 4.5, our median is 5, and our mode is 5 on number 1. Okay, hopefully you got that. Let's check number 2. So for our mean on this one, I have not yet added them all together. So I need to add those all together. I'm going to grab my calculator here. Just for reference, my calculator that I use on my phone looks just like the one we do in class. Looks like that. And that's my phone. It looks like that. It's an app called Wabbit-emu, like WABBITEMU. And it's free, and it's just like an emulator for the calculator. Cool. Okay, so I need to add all these together. So it's 10 plus 12 plus 16 plus 10 plus 11 plus 9, 13 plus 11 plus 8 plus 11. All those, I got 111 for that. So for my mean, I have 111 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, so that's going to be 11.1. Assuming I added all those together, it's always a good idea to double check. Our median here, I have to write these in order. So the smallest number I have is an 8 and then a 9. So there's my 8, there's my 9. I have 2 10s, 10, 10, and then I have 1, 2, 3 11s. 1, 2, 3 11s, and then I have a 12, a 13, and a 16. Perfect. So my median, once again, I have 10 numbers. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 should be right in between. 11 and 11 is just 11. If those numbers were not the same and we needed to find the number in between them, one way you can always do it is add the 2 numbers together and then divide by 2. That'll find you the number right in between. And then lastly, we need the mode, which is the number that appeared the most, which in this case is 11, and appeared 3 times. So just to double check, we got our mean is 11.1, median is 11, and mode is 11. Okay, so that's all 7.1. And then we're going to look at box and whisker plots. So it says use the box and whisker plot to find these given measures. The least value, well, that's this number right here. That's 2. For number 4, the first quartile. So that's the left end of the box. So that's 5 in this case. Sometimes that's called as Q1. The median is the middle of the box, so that's 6. The range, okay, the range is the biggest number minus the smallest number, and we have that on our 7.1 notes also. So that's going to be 11 minus 2, because that's our highest number up there. 11 minus 2 is just 9. 9. The interquartile range, inter means inside the quartiles, so that's just from 8 to 5, so that's 8 minus 5, which is 3. The right end of the box is 8, the left end of the box is 5, so 8 minus 5 is 3. And the third quartile is that 8, that's the right end of the box. Perfect, we got all those. Least value is 2, first quartile 5, median 6, range is 9, interquartile range 3, and third quartile 8. Then we need to make some box and whisker plots. When we make our box and whisker plots, first thing we need to do is always line up the numbers from smallest to greatest. So we've got a 4 here, we've got 2 6s, 6, 6, I got a 7, just 1 8, and 2 9s, 2 10s, and 2 11s. I think I got all of those there. Perfect. So the first thing I'm going to do is I'm going to find the median because that's the middle of our box. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I'm going to have one right in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 9 is right in the middle. That's my median. So I'm going to go ahead and just put the middle of my box at 9. Then I'm going to look at the numbers to the left here, and I'm going to split those right in half. So that's going to be right through 6 on the bottom end, and on the top end, right through 10 on the top end. So there's my box. And then my lowest value was 4, so I'm going to put a dot there. And my highest value was 11, so I'll put a dot right there. Perfect. Nice. You can see everything on there. Okay, next one, similar process. So the smallest number I have here is 22. So these are much bigger numbers. I have a 31, a 31, 34, 39, 42, and 58. Perfect. All right, the number right in the middle, let's see, 1, 2, 3, 4, 5, 6, 7. So it's going to go right through 34 is the middle. So let's see, it looks like we're counting by 5s here on our graph. So I'm going to go right to the left side of that 35. And there where it's not as obvious, I might write the 34 up above it just to make it really clear. And then I'm going to look at these numbers to the left. So the middle of those is 31 because I just have those 3 numbers. So I'm going to use a 31. I'm going to write that one up above. And then to the right through that 42, I'm going to go right here, label that as 42. That's my box. Smallest number is 22. And the biggest number is 58. So on number 9, I didn't label those points because this number line is just counting by 1. So it's pretty clear where we're going with that. But on number 10, where we kind of have these weird numbers and it's counting by 5s, I think it'd be a good idea to place the numbers up above to make it really clear what you're doing. Okay. The table shows the prices of 8 electronic tablets. Okay. Identify the outlier. So 188, 480. So this one is like much higher than the others, I think we could say. Identify the outlier. So I'm going to say the outlier is 480 and that's a price. Describe one potential explanation. It's an Apple product. No, it might just be like it could have like more processing power, larger processing. Could have more storage. Maybe it's just like newer, something like that. Could also be Apple, just saying. Okay, and down here we're looking at our standard deviation. So this is from 7.1 part 2, that bright pink notes page, or we had a green worksheet with these on them. So we got to look at this bell curve. We need to remember our bell curve. So it tells us the mean is 35, so I'm going to put that right in the middle. And then the standard deviation is 6. So I'm going to go up and down by 6 at each of like the tall marks on this bell curve. So up and down by 6 puts us at 41, 47, plus 6 is 53. And then I need to go down also. So that's 29, 23, and 17. Perfect. So I got that all labeled up. What percent of scores are between 23 and 41? So between 23 and 41 is all of this stuff right in there. That's between 23 and 41. So we need to add up those 3 percentages, 13.5 plus 34 plus 34. So 34 plus 34 is 68. So that's 68 plus 13.5, which I'm struggling to do in my head. So I'm going to grab my calculator just to make sure. Let's see, 68 plus 13.5 gives me 81.5. So I'd say that is 81.5%. Okay, and I'm going to erase that highlighting. All right, in between 17 and 35. So 17 and 35, there's 17, and here's 35. So it's going here. If we go all the way to the left, that's 50%, and I'm just losing that tiny little tail to the left at 0.5, so that's going to be 49.5%. 49.5%. And what percent of scores are greater than 47? So greater than 47 is pretty rare. Here's 47 over here. So greater than 47 is going to the right. That's that 2% plus that 0.5%. So that's just 2.5%. Nice. Okay, on the last test, the average score was 78. I'm going to put that right in the middle. And the standard deviation was 9. So I'm going to go up and down by 9 at every one of those big tick marks. So if I go up by 9, that's going to put me at 87, and then 96, and then 105. I need to go down by 9. So if I need to go down by 9, I'll probably go down by 10 and then add 1. So that would put me at 68, but then add 1 would be 69. If I had to go down by 9, that would be 60, and that would be 51. All right. Got those. What percent of students scored below a 60? So here's 60 right there. And below a 60 is just to the left. That's that 2% and that 0.5%. So that's 2.5. And the last thing it says is the hardest type of question you'll see on here. It says, in a class of 1,000 students, how many scored below a 60? So we already know the percentage below a 60 is 2.5%. So we need to do 2.5% of 1,000. And when I calculate that, I have to remember that the percent is like out of 100. So really I need to do 0.025 times 1,000, which I believe is going to be 25 students. So 25 students out of 1,000 we would expect to score below a 60 because it's pretty rare to score that low based on that normal curve. The average was a 78, so we'd expect most students to be in between like a 69% and 87%. Okay, we'll flip it over on the back. Tell whether the data are qualitative or quantitative. So remember, quantitative is like numbers and qualitative is like categories or labels, like blue eyes or something like that. Pairs of shoes owned. So number of pairs of shoes owned, that could be quantitative. Brands of athletic wear. Brands, that's like brand names. That's going to be qualitative. Type of car you want. A type of car, that's going to be qualitative as well. And number of siblings. So that's a number of siblings. That makes sense. So we could average, find out like how many siblings our classmates have on average. So that is quantitative. Remember to be careful those ones we talked about in the notes, like jersey numbers or telephone numbers that are numbers, but it doesn't make sense to average them. So they would still be qualitative. Okay, find the value of X. These are some pretty hard problems. This also came from our blue worksheet right at the beginning from 7.1. So they're going to tell us what the mean is, and we have a missing variable. So remember, the way we set this up is I have 1, 2, 3, 4, 5, 6 things that I need to add together. So if I was able to add all these together, the 8.5 plus the 9 plus the 7.5 plus 6 plus 5 plus X, I would need to divide by, I already forgot that number, 4, 5, 6. And it's saying the mean, that should be 7. So what I'm going to do is I'm going to add all those numbers that I can together. Grab my handy dandy calculator here. So I'm doing 8.5 plus 9 plus 7.5 plus 6 plus 5, and I don't know how to add the X. So that's 36. So this is 36 plus X over 6 equals 7. And the easiest way to solve this is to get rid of our fraction on the left by multiplying both sides by 6. So I'm going to multiply both sides by 6. That leaves me 36 plus X equals 7 times 6 is 42. And then I just have to subtract the 36 from both sides to find out that what we're missing, X is 6. X equals 6. And you could always go back and double check that. You could put that in and then calculate the mean and make sure that it ends up being 7. Okay, and on the next one, same idea. We need to add all these numbers up. So 5 plus 3 plus 6 plus 5 plus 1 plus 4 plus X, all divided by 1, 2, 3, 4, 5, 6, 7 numbers is supposed to be 4. So I'm going to add up all those numbers that I can. Let's see, that's 10, 20, 24. 24 plus X. I hope that's right because I did it in my head. 24 plus X over 7 equals 4. We're going to solve this by multiplying both sides by 7 to get rid of that fraction. Then I have 24 plus X equals 28. So 24 plus what is 28? That's got to be X equals 4. And that seems reasonable within those numbers. It would make sense to be about 4. Perfect. Okay. This is a double box and whisker plot. So you can see we have 2 box and whisker plots. There's kicker A and kicker B. And we're looking at length of field goals made by 2 football kickers. So which kicker has a bigger range? So bigger range just meaning all the way from like longest to smallest. And I think that's going to be player B because it's going all the way out to what looks like 36 down to 24. So that's a 12 range from 36 to 24. And this guy, it looks like he's going from 31 down to 22, which is only 9 in range. So kicker A, the blue one on my page, has the longer range. Okay. 25% of kicker A's kicks were more than blank yards. So remember when we're talking about box and whisker plots, each whisker and each part of the box is 25%. So if it says 25% of kicker A's kicks were more than blank yards, I'm looking at this top 25% right here. So that is right above, let's see, that Q3 is at 32. So 25% of kickers A's kicks were more than 32 yards is what it's saying there. And it says 50% of kicker B's kicks were less than. So I'm looking for less than 50% is going to split my box right down the middle at the median right here, which is right at, looks like 27. So 50% of kicker B's kicks were less than 27 yards. And lastly, which kicker has the single best length? So the longest length was kicked by kicker A, and that was 36 yards. So kicker A with 36 yards. The longest kick. Perfect. Nice. So that's how we can interpret that box and whisker plot. All right, almost done. Here's the last one. So this is the table shows the times it takes to cook 15 meals. So we have 15 minutes there. Yep. Display the data in a histogram using 4 intervals, beginning with 11 to 30. So on our assignment, we practice this and on our notes. So I need to make a frequency table. So I'm going to do times and frequency. This is like where we did tally marks. And it says the first one's supposed to go from 11 to 30. So that's counting like 20 minutes almost. So my next one should go from 31 to 50, and then 51 to 70, and then 71 to 90. And I think that's going to encompass all of them. So you need to make sure that each one of those bins or each one of those groups has the same amount in it. That's like 19 in each of those. And it told you to start with 11 to 30 and use 4 of them. So we have 4 of them. And now I need to go through this little chart with all the times and make like tallies for which group they go in. So like 25 goes from 11 to 30, 20 goes from 11 to 30, 27 goes in there, 18 goes in there, 40 goes down here, 65 goes in here, 50, 35 goes in here, 35 again goes in there, 40, so I get to cross that one off, 40 again, 58, it's going to go in here, 90 in that topmost one, 38. Man, I wouldn't want to spend an hour and a half cooking dinner. Okay, and 20 minutes, go right up there. Perfect, so I got 5 in the top, I got 7 here, 2, and 1. And that adds up to 15, so I think I probably did okay, probably. And then we're going to create a histogram here, so I need to put my groupings down on the bottom. I'm going to split that into the 4 groupings, so this will be 11 to 30. This will be 31 to 50. This will be 51 to 70. And this will be 71 to 90. And the highest frequency was 7. So I think I can just count by 1. So I can do like 1, 2, 3, 4, 5, 6, 7. Yeah, that'll be great. Perfect. All right, so I'm ready to draw my boxes. So 11 to 30, there were 5 meals that took between 11 and 30 minutes. And that's awesome because I would cook those because I'm lazy. 31 to 50 is going to go up to 7. There were 7 meals. 31 minutes still isn't that bad. At least that's less than an hour. And then 51 to 70, there were 2 meals that were 51 to 70 minutes. So 2 meals right there. And then only 1 meal that took 71. That's a 1 there. 1 meal that took 71 to 90 minutes. And I'm glad because that's way too long to cook dinner. Perfect. Okay. So we got that histogram made. That actually looks really good. I'm very proud of myself. And it says, is the data symmetric, skewed left, or skewed right? And remember our trick for doing this, if I put my pencil right at the highest point, so that's right up here, which side has a longer tail, and it's off to the right. That right side has a longer tail. So it's skewed right. Meaning that there are like outliers to the right is what that means, which makes sense because this 1 meal that took 90 minutes, I would definitely say that's an outlier. There was nothing really close to that. It was way more than the other times. Okay, well, I hope we got through everything. Hold on to your questions. I can go over them in a little bit or ask your friends, but I think we got through that whole thing in there, skewed right. Please study this and be prepared for tomorrow. Get your stuff organized so you can have all your notes, all your assignments ready to go. It'd be good to have some examples ready to go so that you feel really confident tomorrow for the test. And if you want to come in at PAC to ask some questions tomorrow, that'd be awesome. I'd be there to do that for you. But all the best and good luck.